Hello dear students, welcome back to a new lesson. In this lesson we're going to be talking about everyday forces. Now in the previous video we talked about and we finished the 3 laws of motion, and in this lesson we're going to be talking about everyday forces. So the first force that we have is weight. Weight is basically the gravitational pull on an object. Okay, it can change based on location, and it's different from mass. Mass never changes because mass is the amount of matter in an object. So imagine you have a sack of apples or tomatoes. If you change the location of it, the number of apples or the number of tomatoes, they don't change. For example, you take it to the moon and you see that if you had, let's say, 10 apples, there are going to be still 10 apples. But what changes is the gravitational pull on it, which we call it weight. Okay, and weight is denoted as Fg, and it's measured with Newton because it's a force. And we also say that F is equal to Fg is equal to mass times gravity. Okay, don't forget that because it's vertical. That's why we're going to have to calculate gravitational acceleration. The weight of an object depends on 2 things. It depends on the mass. The greater the mass, the more weight the object has, and also on the gravitational force. Okay, if you increase the gravitational force, of course the weight is also going to increase. I'm not going to cover everything in detail. I'm going to directly talk about everything here. We have also normal force. So let's say you have a table and there is a book on this table, or take any other object. Okay, let's say there is an object on this table. Because this object is having a mass, so it has it has Fg, which is equal to mg2. Okay, be careful. Now this book or this object applies a perpendicular force. Be careful, not opposite to the gravitational force, but perpendicular to the surface. So this is going to be, if we make it into a different color, this is going to be Fn, and we call this F normal. Okay, does it have to be always opposite to the gravitational force? Not necessarily. Okay, so let's say you have an inclined place like this, and you have an object rolling down. Okay, you know that this object has mass, so it's going to be like we draw an arrow from its center of mass. So let's say the center of mass of this object is here, and this is called Fg. What about Fn? Fn is going to be, I said, perpendicular to the surface. So this is the surface. Fn is going to be like this. So this is going to be Fn. Now, we also have friction. Of course, when you have 2 objects sliding over each other, we have friction. Okay, so friction is basically the opposing force. Okay, when 2 objects are sliding, we have 2 types. We have static friction, we call it Fs, and we have kinetic friction. To find Fs, we have an equation which is Fs is equal to mu s multiplied by Fn. Okay, and for kinetic friction, we're going to see Fk is equal to mu k multiplied by Fn. Fn can also be mg. Be careful. Now, what is static friction? What is kinetic friction? Static friction is basically how much force do you need to start an object. Okay, and kinetic friction is how much force do you need to keep an object moving. Okay, this is basically the difference between mass and weight. Mass is measured in kilogram, weight is measured in Newton. Mass is the amount of matter in an object, weight is the force applied by the gravity. Mass is a scalar quantity, doesn't have direction, but weight is toward the center of Earth, or toward the center of the moon, or toward the center of any planet, Mars, Venus, or any other planets. This is normal force, as I said, it's perpendicular to the surface. Then we have friction. We have 2 types of friction. We have kinetic friction, and we have static friction. This table is basically the coefficient of friction. So we call these mu, we call it coefficient of friction. This is coefficient of friction for static friction, and this is coefficient of friction for kinetic friction. Now, if you notice that mu s, or coefficient of static friction, is always greater than the coefficient of kinetic friction, okay? That it's always difficult or to start moving an object than to keep an object moving, okay? So let's start solving some questions. The calculating the static friction or kinetic friction or coefficient of friction is really easy. If an object is stationary, you're gonna calculate the static friction. If it's moving, you're gonna calculate the kinetic friction. So it says a 20 kilogram crate initially at rest on a horizontal floor. So it says it's at rest and requires a 75 Newton. So this is going to be what? This is going to be the static force, okay? The static friction. Horizontal force to set it in motion. So the object is not moving, okay? Find the coefficient of static friction between the crate and the floor, okay? So you know Fs is equal to mu s multiplied by Fn, okay? Now I need to find this one. Mu s is equal to what? It is equal to Fs divided by Fn. We have Fs, which is equal to 75, but we don't have Fn. Be careful, we have mass. I told you Fn can be also mass times gravity. 75 divided by the mass, which is equal to 24, times 9.81. Mu s is equal to 0.32. Okay, it's pretty easy. Once the crate in sample problem 3c is in motion, a horizontal force of 35 Newton keeps the crate moving. So this is going to be what? This is going to be kinetic friction, which is equal to 53 Newton. Find mu k, the coefficient of kinetic friction. Okay, so you know kinetic friction is equal to mu k multiplied by Fn. I need to find this one. So mu k is equal to what? It is equal to Fk divided by Fn. I have Fk, which is equal to 53. Fn is going to be mg. So 53 divided by 24 multiplied by 9.81. So you're gonna get 0.23. Okay. Question A, it says a 25 kilogram. You know what? Just let me check this one. I got curious. 53, 24 multiplied by 9.81. Yeah, 0.225. That is basically 0.23. But without units, be careful. Why? Because I forgot to mention this. Because you know this is force, it's measured in Newton. This one is also measured in Newton. They cancel. So the coefficient of friction is basically the ratio. Okay. It says a 25 kilogram chair initially at rest on a horizontal floor requires a force of, so this is Fs. Why? Because it's at rest. To set it in motion. Once the chair is in motion, so this is going to be what? So Fs is equal to 365 Newton. Once it's in motion, a 327 horizontal force keeps it moving. So Fk is equal to 327 Newton. Moving it at a constant velocity. So A, it says find the coefficient of static friction. Okay, so mu s is equal to what? B, find the coefficient of kinetic friction. So mu k is equal to what? So you know mu s is equal to Fs divided by Fn. I have Fs, which is equal to 365 divided by Fn becomes Fn is equal to mass times gravity. going to write that here. So mass is equal to 25 times 9.81. You're going to get 1.48. So 1.48. Okay. Make sure I have written the answers so I don't waste time calculating. So please make sure that this is the correct result. And then mu k is equal to what? It is equal to fk divided by fn. Fk is equal to 327 divided by Fn, which is mg times 9.81. You're gonna get 1.33. As you see, mu s is always greater than mu k. This was question 2. Question 3, I'm gonna leave this for you. Just a simple note. Use the table I just showed you. This table here. Use this one, okay, to solve question 3. It says find fs and find fk for the following situation. If you have 145 kilogram, so for A, you know that fs is equal to mu s multiplied by fn. I have mu s, go back to the table, and fn becomes mg, okay, because I have mass. And for fk, it is equal to mu k multiplied by fn. I don't have fn, so it's going to be mg. Go back to the table and find mu s and mu k for aluminum, okay? And then this one too, and this one too, a sword across a horizontal steel. And please do this yourself because they're really, really easy. I'm gonna move on to sample problem 3D, which I think this one is really important. It says you have a student that moves a box. Okay, I'm gonna do this here. Yeah, here is good. You have a student, okay, he moves a box using, let's do this better. So you have a student, he moves a box and he uses a force of 90 Newton, okay, at an angle of 30. Okay, so let's say this is the box, okay, and of course this box has Fg, and as we studied, this box also has Fn, which is the perpendicular force applied by this object. Be careful. The mass of this box is equal to 20 I think, if I'm not mistaken. Let me go back and check. Yeah, the mass is 20 kilogram, and the mu k is equal to 0.5. Okay, now it says what is the resultant? The F net is equal to what? Now this is pretty easy, and you just have many forces to deal with. Okay, now you know what? Let's make this one bigger. I'm not going to do this on the other one. You know that this FA is going to be analyzed into two components. This is going to be FAX, which is equal to FA cosine theta. Why cosine theta? Because the angle is made with the x-axis, okay? And also we're going to have FAY, which is equal to FA sine theta. Okay, be careful. So I have two forces now. I'm not going to be needing this anymore. Okay, I'm not going to be needing this because I analyzed it into two components. Okay, don't forget because the object is moving, so I'm going to have another force which is called what? Which is called Fk. Fk is always opposite to the motion of the object. The object is going to the right, and the Fk is going to be to the left. Now, I also have something else, which is the force that is applied by the box on the surface. I'm going to call this Fn. Also I have something else, which is the mass of the, or Fg, the weight of the object, which is going to be mass times gravity. Okay, be careful. The question didn't give me the weight of the object. The question gave me mass. Don't be confused. You can just use the mass to find the weight of the object. Now, how can we find the net forces on this object? Please, whenever you have a question like this, first thing you should do is find the net force on this object. Sorry, the normal force on this object. In here, we don't know normal force, but we can find it very easily. Okay, now I'm going to say the sum of all the forces on the y-axis, which is negative, and the sum of all the forces on the positive y-axis. Okay, so on positive y-axis, I have Fn plus, I also have this one, which is Fa sine theta. On down, which is negative, what do I have? I have Fg. Okay, now you can also do something else, by the way. You can say that the sum of all the forces, okay, your teacher might have done it like this. You can say the sum of all the forces on y-axis is equal to 0. Doesn't matter. What do we have on y-axis? We have Fn plus, we have Fa sine theta, and we have Fg, which is, because it's down, so I'm going to make it negative g, so this is equal to 0. What I do is exactly the same thing, but I make it shorter. Okay, now we have Fn, we have Fa sine theta on the positive side, and on the positive and the negative side we have Fg, but don't use any signs. Okay, just write them on different sides. This one on positive, this one on negative, but don't add any signs. Now I'm trying to find this Fn, so Fn, move this to the other side. Fn equals what? It equals Fg minus Fa sine theta. Okay, now I said Fg is going to be what? Is going to be mg, okay, minus Fa sine theta. Mass is equal to what? It is equal to 20 times 9.81 minus Fa is equal to 90 multiplied by sine of 30. So Fn is equal to what? Let me check. Fn is equal to 151.2 Newton. That is my Fn. Be careful. Okay. Now, what about the x-axis? What do we have? So the sum of all the forces on x-axis, we have what is equal to 0. Okay. Now, what do we have on x-axis? We have Fa cosine theta, and we have Fk2. Okay. Now, the sum of all the forces on Fx is going to be what? Is going to be Fk, Fa cosine theta. Okay. Be careful, because the forces on y-axis, like for example, the student is pulling this box, but it's only moving on a horizontal axis, so the sum of all the forces on y-axis are equal to 0. The only forces that contribute to the motion of the object are on the x-axis. Be careful. Okay, so what do we have here? We have Fa cosine theta, which is on positive side, minus Fk. Okay, be careful. Now, Fa we have is 90, cosine theta, so we have is 30. We don't have Fk. Okay, so if we continue writing this, we're gonna have this. So we have Fa, which is 90, multiplied by cosine of 30 minus Fk. I don't have Fk, so what should I do? Let's find Fk. So Fk is equal to what? It is equal to mu k multiplied by Fn. Okay, mu k is 0.5, Fn, we found it, 151.2. Fk is equal to 75.6 Newton. So let's remove Fk. We're going to put in place of it 57.6. The result is equal to 2.3. So 2.3 Newton. This is the sum of all the forces. So the sum of all the forces, F net, is equal to 2.3 Newton. You might say again, why only F, like X, why only the force on X-axis? Just please do this. Pull an object on a floor and you're going to see that Y-axis doesn't move. It's only the Fx, okay, or the X-axis that is moving. The object is moving on a straight line. So question 1, it says, a worker moves a box of books down the hall by pulling on a rod attached to the box. So before I analyze it into different components, I'm going to draw this for you. So you have a worker that is trying to pull a box. The FA he applies is equal to 185 Newton. The angle that it makes is equal to 25. Okay, it says that the mass of it is equal to 35 kilogram. Mu k, coefficient of kinetic friction, is equal to 0.27. So it says, what is the acceleration of the box? Acceleration of the box is equal to F divided by M. I don't have F, I have a mass which is equal to 35 kilogram. So let's find force, okay? Now I told you, because this box is moving on a horizontal axis, so there's going to be no force applied on, or no force, or the net force on y-axis is going to be equal to 0. So the net force is going to be 0. Does it mean that no force is acting on it? Of course not. Fg is acting on it and Fe is acting on it too. So this vector is going to be analyzed into two components, but before you do anything, in every question we have two forces, always and always. Fg and we have Fn2. Okay? We have Fg and we have Fn2. Then you analyze this vector into two components. This is going to be Fa cosine theta. This one is going to be Fa sine theta. Of course, Fax and Fay, okay? But I don't have to write that every time. So this is going to be what? This is going to be Fk2. So let's find Fn. As usual, we have to first find Fn. So how can we find that? The sum of all the forces that are on positive y-axis and the sum of all the forces that are on negative y-axis. What do we have on positive y-axis and what do we have on negative? We have Fn on positive plus Fa sine theta, which is equal to Fg, okay? So the sum of all the forces on negative and positive, be careful. Now Fn, we need to find this, so move this to the other side, it becomes Fg minus Fa sine theta. Fg, we don't have it, so we're gonna say mg, okay, because we have mass Fa sine theta. Mass is equal to 35 multiplied by 9.81. We have Fa, which is equal to 185 multiplied by sine of 25. Sine of 25. Calculate all of this, you should get Fn, which is equal to 265.1, I think, something like this. We found Fn, okay? Now, what about the sum of all the forces on Fx? Okay, so Fx is equal to what? The sum of all the forces on Fx. We have Fk, which is on negative, and we have Fa, which is on positive side. So we have Fa cosine theta. Teacher, does it matter or if I write Fk first or if I write Fa first? No, as long as you don't mix the signs, okay? Look, for Fa we have positive and for Fk we have negative, so I'm going to say Fa cosine theta minus Fk. Does it matter if I say minus Fk plus Fa cosine theta? No, it's the same thing. So FA is equal to 185 times cosine of 25 minus FK. We don't have FK. What should we do? You can find it very easily. So FK is equal to mu K multiplied by Fn. We have mu K, the question has given us, which is equal to 0.27 times Fn, which is equal to 265.1 Newton. That is why I always tell you to find Fn first. Now if you calculate Fk, you should get 71.5. So 71.5. Let's make sure we have 0.2 times 265.1. 0.27 times 265. Yeah, we get 71.55. I have written the results so I don't have to waste time on always checking them. So the sum of all the forces on Fx is equal to what? It is equal to 96.07 Newton. Okay, that's it. I found the sum of all the forces. And by the way, because the sum of all the forces on Fy is equal to 0, so the sum of all the forces is going to be 96.07, which is basically the forces on an x-axis. Now, let's use that in the equation. Let's find acceleration. We have 96.07 divided by 35. Okay, you should get 2.77 meter per second squared, I think. Okay, I know it's really annoying. This topic is basically a lot of calculation. You should take a lot of things into consideration, but as long as you practice, I guarantee you that you're gonna do just fine. Okay. Question 2, it says the worker in item 1 moves the box up a ramp at inclined at 20 degrees with horizontal. So you have this time, this guy doesn't stop. Okay, so the inclined place has an angle of 20 degrees. Okay, and this is the box. Okay, I told you always draw FG, because these two forces, we always have them, okay, no matter what. And this is going to be Fn. Okay, now if the box starts from rest at the moment at the bottom of the ramp and is pulled at an angle of 25, okay, so the force applied, okay, this is the force applied, okay, Fa, which is equal to 185 Newton, and it's making an angle of 25. Okay, of course with the horizontal, with the x-axis. So 25. Because the force applied here is to the right, so this is going to be what? Let's use a different color. This is going to be Fk. Okay, so what are you going to do here? Because this Fg is making an angle, okay, with the x-axis and with the y-axis, so this is going to be, let me use a different color, or let me use yellow. So this is going to be x-axis, and this is going to be y-axis. Okay, as you see, this is 25, so the angle 12, sorry, not 25. So the angle here is going to be also 12. Okay, this is going to be what? This is going to be Fg cosine theta, and this one here is going to be what? Here, be careful, is going to be Fg sine theta. Okay, why? Because this Fg is making an angle. It should not be calculated like that. This one too here, okay, let me use a different color. This Fa2 is going to be analyzed into two components, Fa cosine theta and Fa sine theta. Okay, now let's find Fn first, and then it says what is the ramp's acceleration. Okay, acceleration is equal to F divided by F divided by mass. We don't have F. The forces, of course, are going to be on x-axis because y doesn't move. Like the box is not going up and down, it's on an inclined place. It's still a straight line. Be careful, don't confuse that. Now, what do we have on the y-axis? We have Fn plus Fa sine theta, which is equal to Fg cosine theta. We're trying to find Fn. Let's make sure we have everything. We have Fn. This Fn is from the forces applied, and we have Fg cosine theta, which is from this one, which is the weight of the object. So Fn is going to be what? Take this to the other side. Fn is equal to Fg cosine theta, okay, minus Fa sine theta. Okay, now do you have Fg? Do we have mass of the object? It says from question 1, item 1. Let's check item 1 and see what the mass is. The mass is equal to 35. So the mass is equal to 35 kilogram. Because I don't have Fg, I cannot do anything without having Fg. So I'm going to say Fn is equal to mg cosine theta minus Fa sine theta. M is equal to 35 times 9.81 times cosine, be careful, don't say 25, the sine, the angle that this makes with the y-axis, so cosine of 12 minus Fa, which is equal to 185 multiplied by the sine of 25. We're gonna get what? Fn is equal to 200. You know what, let me check that. So we have 35 multiplied by 9.81 times cosine of 12 minus 185 multiplied by sine of 25. You're gonna get 257.6 Newton. I'm gonna be really honest with you. I'm sure some of you are pulling your hairs right now because you're really angry at this question. Okay, and some of you might be disappointed at how difficult this is. Yeah, I cannot be like, I can't lie to you. Yeah, this is really complicated, but as long as you start solving this again and again, you analyze the things that you have problem with, believe me, it's going to be really easy. It's not as complicated as it seems, but the first thing you're watching this video and you're just basically looking at how I do this. But if you don't start taking notes, if you don't start solving this yourself, yeah, it's going to be look difficult. So please grab a pen and a pencil or a paper and start solving or practicing on this. We found Fn, and let's find the sum of all the forces on x-axis. So the sum of all the forces on x-axis, okay, what do we have? Fx is going to be what? Is going to be, we have Fa cosine theta, which is on the positive side, and we have minus Fk minus Fg sine theta. Okay, be careful. Can I write Fk and Fg in the first? Yeah, but don't make sure that this one becomes positive. Like, don't add negative to this one. We have Fa 185 times, you know what, let me write Fk, the last one. So we have Fg sine theta minus Fk. 185 multiplied by cosine of 25 minus FG is going to be what? FG is going to be mg. Okay, be careful. So mass, which is equal to 35 multiplied by 9.81 multiplied by sine of 12 minus, do I have Fk? No, I don't have Fk. Okay, so let's find it. Fk is equal to what? Fk, it is equal to mu k multiplied by Fn. We found Fn and we had mu k2. Mu k is equal to 0.27. So 0.27 multiplied by 200, we found Fn to 257.6. You're gonna get 69.56. So Fk is equal to what happened? So Fk is equal to 69.56 Newton. Okay, now we have 60. Instead of writing Fk, I'm going to write 69.56. The sum of all the forces on Fx is equal to 26.7 Newton. Now let's use that on the equation. Why do you use Fx instead of for F? Because the sum of all the forces that are acting on or contributing to the motion of this object is only Fx. Fy, the net force on it is 0. Okay, but the force on Fx is equal to 26.7. So 26.7 divided by mass, which is equal to 35, you should get 0.77 meter per second squared. This was question 2. I'm going to leave the rest of the questions for you. They're really I just really like this question. Okay, they're not that different. Okay, I'm going to solve question or just explain question 4 for you. It says a box of books weighing 325 Newton. So if you draw the coordinate system, you have a box. Okay, this box has a weight of, so Fg is equal to 325 Newton. You know that you have Fn2, okay, without doing anything. And a constant velocity across the floor when it is pushed with a force of 425 Newton exerted downward at an angle of 35.2. So this one is moving like this downward and it's making an angle of 35.2 Newton. Fa, which is applied, is equal to 425 Newton. What is mu k between the floor and the box? So mu k is equal to what? Okay, so you know that mu k is equal to Fk divided by Fn. First find Fk and then, or first find Fn and then find Fk. But be careful that this Fa is going to be what? This is going to be Fa cosine theta. And this one is going to be what? It's going to be Fa sine theta. The object is moving to the right, so this is going to be Fk. Okay, now let's solve this question. Okay, now on the y-axis, positive 1, we have Fn and we have Fg and we have Fa sine theta. So Fn is basically going to be what? Fn is alone, it doesn't have any other positive forces on it, so it's going to be Fa. It's going to be Fa sine theta plus Fg. Okay, Fa is equal to 425 times sine of 35.2 plus Fg, which is equal to 325. Fn is equal to what? It is equal to 570 Newton. Let's find Fk2. So with Fk, what do I have? Like with Fa. So we have Fa cosine theta. Okay. And then what do I have on the other side? We have we only have Fa cosine theta, and we have Fk2. So it's going to be Fk. So Fk with Fa cosine theta. Fa is equal to 425 multiplied by cosine of 35.2, which is equal to Fk. Fk is equal to 69.50, is equal to 348.13. Okay, now let's find mu k. We found Fk, which is equal to 348.13. Divide this by Fn. Fn is equal to what? 570. Mu k is equal to 0.61. Let's check that. 348.13 divided by 517. Yeah, 0.61 without any units. That's it. Like the sample problem 3D. Air resistance is also a form of friction. For example, somebody is using a parachute. Air resistance is applying a force upward, and the gravity is applying a force downward. So air resistance is always opposite to the gravity. I'm going to solve question 2 because it's an important question. It says a bag of sugar has a mass of, so mass is equal to 2.26 kilogram. Okay, and what is its weight? So F is equal to what? On the moon, where the acceleration due to gravity is 1/6 that on Earth. If you know that F is equal to 1/6 of what? Of gravity on Earth. Okay, so what can we do? You can first find the it says that if the gravity is 1, so if gravity on moon, not F, is equal to 1/6 of gravity on Earth. So what can you do? You can first find this and divide it by 1 over 6, or multiply by 1 over 6, or you can just apply it in the equation. So we have F, which is equal to mass times gravity. We have mass is equal to 2.26 multiplied by, make a parenthesis, this gravity is equal to 1 divided by 6 multiplied by 9.81. Okay, so if you calculate this, 9.81 divided by 6, because you know it gets here, and then multiply this by 2.26, you're gonna get 3.69. Okay, so force is equal to 3.69 Newton, or 3.7. B, what about Jupiter, where the acceleration due to gravity is 2.64 times on Earth? This time, gravity on Jupiter is equal to 2.64 gravity on Earth. Okay, Earth. So what are we going to do? We're going to say F is equal to mg. Mass is equal to 2.26 times instead of writing gravity 9.81, I'm going to write 2.64 multiplied by 9.81. You're going to get 58.5 Newton. This is it for today. I'm going to leave the other questions for you. I'm sure they're going to be really easy. Most questions, because like if you have understood all these questions, all the other questions are basically like this. Like they can't be any different than these questions. You either have you find the net force on the object, and you're gonna find the acceleration of the object. Or sometimes the question asks for mu k. Okay, so this is for today, and see you in the next chapter, which is chapter 4, and have a good day.